Good evening, guys. So here is the video for the stoichiometry notes. This is what we've done in class yesterday, and for some of you guys, it was today as well. So I'm going to go over this with you guys real quickly. And if you have any questions, please come in after school during lunch again to get that extra help. Alrighty. So the essential question for today is how do chemists use stoichiometric calculations to determine that's a bad too to determine quantities. Whoops, that is a little off. To determine quantities to determine quantities of compounds and reactions. So of compounds in reactions. Okay. That's our essential question. How do chemists use stoichiometric calculations to determine quantities of compounds in reactions? Okay, so that is the central question for us today. Sorry. There we go. Get that cursor out of the way. It's a little bugging. So yeah, that's our essential question today. So in stoichiometry, we've already talked about it for a little bit, but here it's used to compare relative quantities of compounds in a reaction. Okay. So whenever we're comparing quantities of compounds, we are always going to be using moles. Okay. This is our staple unit that we're using. Okay. Moles are important because we can make mole ratios. These mole ratios are used to convert from one compound to another compound. Okay, so it's very, very important that we understand how we could utilize the moles of one compound to be able to convert into another compound. Okay, so this is our portion of our vocab that will be very important for us to understand. Okay, so here's our stoichiometry, guys. So in this part, I want you to think about these 8 circles as a roadmap. This is going to help us to go from mass to moles to moles to mass, liters to moles to liters, or from mass to moles to liters. Okay, this is a roadmap. All 3 of these left circles are our given quantities. Okay, these are our known values. And we're able to convert from these known values to moles. And then from moles, we convert to another form of moles. And then we go to our unknown values that we're looking for. Okay, that is our roadmap. So here we go, one by one. Let me zoom back in. Just makes it a little bit easier when we write. Okay, so for our known units, this is going to be for one particular compound, okay? So we're going to call this compound 1, okay? Our compound 1 is always what we know. This is what's given in the problem, okay? So the volume is going to be our first, it's going to be our first unit that we work with, okay? Each of these 3 left circles they all want to go, as you could tell, to this middle box. This middle box is always going to be moles. We always want to convert to moles. Okay. In order for us to go from volume to moles, we have to use a conversion factor. That conversion factor will always be 22.4. Okay. We're always dividing 22.4 with a given value. And when we do this, we get moles. Okay. And then once we got moles, we have to convert to the moles of the second compound. Okay, so the second compound we're going to call compound 2. Okay, this is the one that we're looking for, or it's unknown. We don't know what it is yet. We don't know what that value is that we're looking for. Okay, the only way that we could get this unknown quantity of moles, we have to use the mole ratio. We have to use this, okay? This is when we use the coefficients in the balanced chemical equation, and we get the coefficient of our unknown value, and we put it over the coefficient of our known value. Okay, so that's our fraction for mole ratio, and that's how we're going to be able to convert from 1 mole to the next mole. Okay, that's essentially our method to go from moles to moles, okay, using the mole ratio. Okay, so once we got moles here, then we use our conversion factor again to get to the volume of that second compound. Remember, we want to get to the liters. So if we divided by 22.4 in the beginning, what do you think we're going to have to do here? We're going to have to multiply that 22.4. Geez, that's terrible too. 22.4. Okay, we always divide on this side when we're going from quantity, a known quantity, to our moles. And then when we have our moles, we always multiply to get to our unknown value that we're looking for. Okay. All right. Next step. Say that we have a mass of a known quantity, okay? And that mass is always going to be given in grams. We're going to have to go from mass to moles by using our molar mass. Okay, we've done this before. This is not new. Okay, we use molar mass to go from mass to moles. And then we have to use our mole ratio to go from moles to moles of the unknown quantity. Then say if we have moles of the unknown quantity and we want to go to the mass of our unknown quantity, we're going to have to multiply by our molar mass. Okay. This is a vital step when we're going from moles to mass. Okay, we have to know the molar mass of that unknown compound. Okay, so this is still for the unknown compound. Okay, still for our unknown compound. All right, and the last one that we'll be working with is particles. Okay, so that accounts for our atoms and our molecules. Okay. Now, the operation that we're going to have to do is we're going to have to, again, divide. We are going to have to divide. Oh, that looks like a percent sign. Let me erase that. Okay. When we divide, we're going to be dividing the Avogadro's numbers, 6.02 times 10 to the 23. Okay, that's what we have to use in order to get to moles from particles. Okay, and then right over here, we're going to have to multiply 6.02 times 10 to the 23rd power. Okay, in order to go from the moles of our unknown to the particles, of our unknown. And remember, this still accounts for atoms and molecules. Okay. All right. So our next step, what we'll be doing, we're going to do an example going from mass to mass of this word problem. Okay. The word problem states how many grams of water are produced when 158 grams of aluminum hydroxide decompose. So with this, the first thing we want to do is we want to underline what's given. What is the given value in our problem statement? Well, that given value is 158 grams of aluminum hydroxide. Okay. Next step, we want to circle what we're looking for. Okay. Typically, what we're looking for is always going to follow how many. Okay. It's going to follow how many something. How many, in this case, is how many grams of water. Okay. So let's go ahead and circle what we're looking for. So this is the unknown. And this is the known. Okay. So now let's work through this problem together. Okay. So our known is 158 grams of aluminum hydroxide. Okay. What we don't know is the grams of water. Okay. So we're going to have to go through steps 1 through 3 in order for us to determine what is it that we're looking for. Okay. So let's go ahead and continue with the problem. Okay. So the first step that we always have to do is we write down what's given. Okay. So what's given is 158 grams of aluminum hydroxide. And we always put that over 1. Okay. And based off of our roadmap, we're going from, again, mass to mass. The first step that we have to do from mass is we have to go from mass to moles. First thing that we have to do is we have to divide by the molar mass. Okay? So when we do that, we have to calculate the molar mass. So we see that we have an aluminum, we have oxygen, and we have hydrogen. How many aluminums do we have? We have 1. How many oxygens do we have? We have 3. Okay, that's right here we're looking at. We're looking at here for our molar mass. Okay. Man, I cannot make arrows. Why did it do that? Sorry about that. Let me try and make a better arrow here. There we go. The molar mass. And then how many hydrogens we have? We have 3. Aluminum, we looked at our periodic table and we see that aluminum has an atomic mass of 27. Oxygen has an atomic mass of 16. And hydrogen has an atomic mass of 1. For this case, we will use 1 instead of 1.01 that we use in class. So we do the multiplication and we get 3. 3 times 16 is 48. 1 times 27 is 27. And then when we add all these together, we get 78 grams per mole. Okay? Whoa. We get 78 grams per mole. Okay? So then we go ahead and we divide. We're having some technical difficulty here, guys. I apologize. Why did you erase everything there, buddy? Sorry, guys. You guys will be able to fast forward this as you're watching the video. I accidentally erased all my work right now. There we go. That looks better. Okay. All right. So it's over 1. Let me draw my bar again. Okay. So we're going to divide. We're going to divide by the 78 grams per mole. And then when we do this, we notice that since we're dividing, these grams will cancel out with these grams. And we will be left off with 2.03 moles of aluminum hydroxide. Okay. Now this is an important value. Okay. That value we're using for our next step. So we go ahead and write the 2.03 moles of aluminum hydroxide right in here. 2.03 of aluminum hydroxide. Okay. And we're trying to figure out where our next step is. Okay. Whoops. This should be, this should be moles in here. Okay. Our next step is we're here in moles already. We're right here. Now we want to go from moles to moles of the other compound that we're looking for, the unknown compound. This is what we're looking for. So we go back to our equation and we figure out, what are we looking for again? What is it? What is the compound that we're looking for? And we see that we are looking for water. Okay. Since we're looking for water, that means I want to be able to convert into moles of water. That's what I'm looking for. The unknown value is always on top. Going back to our mole ratio fraction right here, that's what we're looking for, the coefficient of the unknown. That's on top. Okay, so let's look at our balanced equation. Here's our balanced equation right here. Let's look at all of our coefficients. So here's a 2, here's a 1, and here's a 3. Which coefficient are we going to use for water? We are going to use the 3. Okay, so the 3 moles of water goes on top. And then the coefficient of what we know already goes on the bottom. So the mole of aluminum hydroxide is on the bottom. Okay, and if we look at our equation, we see that it is indeed a 2. All right. Now the next step from here, we take all of these values, 2.03 times 3, and divide it by 2, and we plug that in our calculators. Okay, and then when we do that, we see that we get a value of 3.05 moles of water. Okay. Now again, we're going to be using this next value in our next step. Okay. And this will be the very last step till we get our final answer. Okay. So now we are in the moles of our unknown compound. Okay. Grams of water. That's where we want to get to. So we're in the moles of our unknown compound. Okay. So we're right here. We're at moles. So our next step, we have to look at our roadmap again. We're right here at our moles of our unknown compound. Now we have to multiply by our molar mass. That's our next step. We have to multiply by our molar mass. Okay, so next, what we're going to do is we're going to take what's given. We're going to take 3.05 moles of water. We're going to have to divide it by our molar mass of water. Well, we haven't done that yet, so we have to get our molar mass. Same thing like how we did aluminum over here. Hydroxide. We have to do the same thing. Okay? So, what we do is we count all our atoms. And we see that we have two hydrogens. And we're going to multiply by 1. And we have how many oxygens? We have 1. We're going to multiply by 16. And when we do all our math, we see that we get 2 plus 16. And when we add those together, we get 18 grams per mole. Okay? So we plug that value right in here, and we get 18 grams per mole. Then when we do this, whoops, we don't divide. Sorry, guys. Mr. Delgado did something wrong. We don't divide. We multiply. My apologies. Then when we do this, we see that moles cancel. And when we do the calculation, we get a value of 54.9 grams of water. And this, ladies and gentlemen, is our final answer. Okay, we found the unknown quantity that we were looking for. Okay, and we got to check again. What were we looking for? We were looking for grams of water. Is that what we got in our final units? That is indeed what we got in our final units, grams of water.